Thank you very much. Good afternoon from my side. My name is Bikas, and I'm a research engineer at the Laboratory for Manufacturing Systems and Automation of University of Patras. And our first topic for today is 4DHYBRID. 4DHYBRID is a relatively new project. We kicked off 8 months ago in January 2017. And the main topic the project is coordinated by Prima Electro. The technical coordination is being done by SUPSI from Switzerland, and the consortium involves a series of very well-known and established companies, as well as some research institutes very well-known on their specific fields. The main objective of 4DHYBRID is to develop a new concept of hybrid additive manufacturing based the whole concept is based on modular integration of compact and low-cost modules such as laser heads and cold spray deposition heads in order to be able to exploit the potential of additive manufacturing in the field of repairing metal structures on field. Solutions created in 4DHYBRID will be tested by end-use cases provided by Siemens, General Electric, and Globotics. These companies I just mentioned cover 3 different industrial sectors. So our first demonstrator comes from the oil and gas sector, and it is provided by Globotics. It is regarding the repair of storage tanks and pipelines for the oil and gas industry. The second one comes from power generation and from Siemens, and for that case, we have to deal with repairing totally different structures. So here we do have blades from gas turbines. And the third one is an aerospace part provided by General Electric. As you see, these 3 different cases are very diverse in nature. What they do have in common is the fact that we need to operate in a harsh environment, especially for the oil and gas industry. Another commonality is that these structures normally are 24/7 in service and on the field. Moreover, we have to deal with very large structures and very complex shapes to be inspected and to be repaired. This, of course, would involve a series of different materials that we need to consider. You can imagine that there is little commonality between gas turbine blade and the pipeline for oil and gas. Therefore, we have to consider not only different materials, but also consider many different technologies. Not only additive manufacturing, but also subtractive, because we also need to be in position to remove any damaged areas prior to repairing with additive manufacturing. Of course, based on the things already mentioned, this means that we will have to start creating hybrid process chains. And hybrid process chains are needed not only because we need to inspect and remove damage before repairing, but also because sometimes the repair actions needed are very different. For instance, you might want to very efficiently and very quickly repair a very large area by using one kind of metal deposition technology, so one kind of 3D printing technology, but then you need to add a very small and intricate detail to a very specific area of the part. And this may require a totally different metal additive manufacturing technologies. In order to do so, we don't only need to investigate the processes that can be integrated and should be integrated, but we also have to translate that to a series of mechatronics modules that can be nested in existing machines or in existing robot frames in order to be able to execute the process. So we consider them as modular heads and as modular processing units, let's say, which can be nested with each other. And of course, in order to be able to control all this and synchronize all the resources together in order to be able to actually operate, we need a modular control platform in the form of an open CNC machine. On top of that, what we need is a software suite, something really similar to what was presented before, to keep everyone involved during the process chain, from engineers back to the factory to workers that actually undertake the repair process, and keep everyone connected, and also be able to trace back the data and keep the data in one place. This role is being undertaken by what we call the 4D engineering suite, which is also part of the development of the project. As mentioned, 4D hybrid takes into account different stages of the life cycle. The first one is greenfield, which pertains to the manufacturing phase of the parts. So here we're talking about manufacturing new parts during the very, very first stages of their lives. We also have to deal with brownfield, though. Brownfield refers to parts that are already in service and have to be repaired. Of course, part of that is also inspection, and that means that, as mentioned, a multitude of different technologies have to be used and have to be combined. This leads us to the point of modular equipment, which was already briefly introduced before. So as the very first step, we do have a series of what we call elementary modules. These are very simple laser heads or a deposition system for powder spraying, or a cold spray head. And these elementary modules can be combined in order to form what we call the 4D hybrid modules, where we might have combinations of powder deposition and laser, or cold spray and laser, or material removal processes such as laser ablation or laser deposition. Of course, these hybrid modules could then be nested in existing CNC machine frames or existing robot arms in order to form a standalone repair solution. What is a very important aspect to discuss, since the project mainly emphasizes on the repair phase of structures, is the use of monitor equipment and software. So at the very first step, the first thing that has to be done is inspecting the structure for damage. Usually this, for the most cases, being done by expert workers, and this requires usually a team of experts to be moved in a very remote location and execute the inspection and the determination of the status of the structure. What we have envisioned for the hybrid is to create the tools in order to not only physically scan the part in terms of capturing the 3D geometry, for instance, or getting visual data regarding the extent of the damage, but also connect that to the 4D hybrid engineering platform. In that way, engineers that are not present on site, but are rather based on a remote location back to the factory, can get the data, can interpret the data, and can guide a non-experienced or non-expert, let's say, worker on what is the appropriate reaction to what is being recorded by the monitoring devices. Another interesting aspect for that is the fact that we can use the platform, the software platform, also as a repository for the things that we monitor and the things that we repair. And this is of specific interest, especially for the oil and gas and aerospace sector, because these people need to have data from their repair phases, and need to store this data in order to allow certification and legislation procedures to be done in a more efficient way. Nowadays, what they're doing is a ton of paperwork, really, especially in the field for oil and gas repairs, and we envision to change that through using the 4D hybrid engineering platform. What you can see here is a series of possible applications. So based on the demonstrators we have identified, you can see different modules, either for cold spray or for laser ablation or for welding, that can be used, and potential ways that this can be used in order to repair either inspect pipelines from the inside or repair pipelines on the outside if they're damaged, but also work in many different cases, such as in storage tanks. What is important with that is the fact that by using a modular concept of equipment and by using different additive manufacturing techniques, what we can do is move the repair phase from the factory on site. And this is very important when we talk about large structures which cannot be very easily dismantled and carried back to the factory in order to be repaired. Usually, especially for very large parts like the ones used on power generation or in oil and gas industry, what they do if they found a problem is actually start a very long, in terms of time, process, which usually involves a very long, physically very long supply chain. Parts have to be ordered, and then they have to be shipped sometimes halfway across the globe in order to reach the facility and then be installed in order to fix any problem that arises. Here, we are thinking of moving mobile equipment on site, not necessarily everything on every site, but we can have mobile units dispatched, and these can solve very efficiently and very quickly the problem by also shortening very much the time needed to actually execute a repair. Here you can see a few pictures. This is actually a couple of months back at the University of Patras, a few moments by our General Assembly, where we got together and also held a workshop with the end users, discussing a bit on the opportunities arising by the use of the 4D hybrid technologies for them. So we discussed different scenarios, and different opportunities came up, and they were validated against their end use cases. These are also publicly available through the website of 4DHYBRID. If you visit 4dhybrid.eu, you may find more information, not only about the project, but also about the opportunities and the benefits arising by such an approach in the problem of repair of metallic structures. And you can also follow us on the social media, and we're trying to constantly update everyone on this front. So during the next few months, what is planned in terms of activities is a big experimental campaign, trying to identify the different technologies that we are going to integrate in the project, try to validate and get results by using different materials in different scenarios. And all this information, or some of this information was not confidential, will be also included on the website. So if you're interested, you can follow us through these channels. Thank you very much for your attention.